Hello everyone, tonight we're going to take a journey through the universe to visit star systems that, frankly, shouldn't be real. They defy gravity, logic, and occasionally common sense. These are places that make physicists sigh and astronomers whisper, "You've got to be kidding me." Imagine you're drifting just beyond the edge of a spiral galaxy. There's no sound, only the deep silence of the void. In front of you is a distant sun. It has a planet the size of Jupiter, beautiful and blazing with the glow of starlight reflecting off its atmosphere. Now here's the thing, it's orbiting backwards. You can either rethink everything or fall asleep without even noticing. So before you get comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. Feel free to drop a comment. Where are you listening from? And what time is it there? Now, turn down the lights, maybe crank up the AC for some soft noise, and let's get started tonight. Section 1. You're coasting through a star system 600 light years away in the constellation Scorpius, and your first stop is a gas giant named WASP-17b. The name isn't cute. The planet is enormous, puffy, and hotter than a pizza oven on maximum overdrive. WASP-17b is what scientists call a hot Jupiter, except this one's got attitude. It orbits its star in the opposite direction of the star's own rotation, like a racetrack rebel, going full speed the wrong way, honking at the laws of physics and flipping off Newton. Planets are born in disks of swirling dust that all rotate the same way. That's the rule. That's how solar systems form. You spin in one direction, and everyone follows the choreography. But WASP-17b, nah. It showed up to the ballet and decided it was a mosh pit. Astronomers noticed this orbital weirdness thanks to something called the Rossiter-McLaughlin effect, a method of measuring how a planet's movement affects the light of its host star. That's how they realized, oh no, this guy's doing donuts in reverse. Scientists still argue about how this happens. Was it flung by another planet, dragged by a passing star? Did it just get really lost on its way to being normal? One theory suggests gravitational chaos during early planetary formation, a kind of cosmic bumper car scenario. Another hypothesis involves something charmingly called planetary migration, which sounds peaceful, but usually ends with multiple worlds being yeeted across space. There's something deeply satisfying about this planet. It's huge, about twice the size of Jupiter, but so bloated and low density that it would float in water if you could find a pool big enough and, immune to temperatures above 1,000 degrees Celsius. Imagine standing on a platform nearby, watching the atmosphere swirl in gigantic loops, clouds of vaporized metals glowing faintly under a sickly orange sky. You're not even sure what weather means anymore. Thunder firestorms, glittery radioactive fog. Probably yes to all. And if you could hear WASP-17b, which you can't, but let's pretend it'd sound like a freight train made of wind, scraping against itself in protest, roaring in reverse. Like it's angry at the very concept of direction. There's a quiet joke among astrophysicists. If it's impossible, it probably exists. That's WASP-17b. It's not just breaking the rules, it's casually insulting them, drinking their coffee, and wearing their socks. Now, you may be wondering, wouldn't this backward orbit eventually mess with the planet? Yep. Tidal forces between the planet and its star are like an invisible bungee cord, slowly yanking it closer. Someday, WASP-17b will spiral in too far and burn up or break apart. But for now, it's out here, moon walking around its star like it owns the place. A fun fact, this planet was one of the first exoplanets discovered to have a retrograde orbit. It helped open the cosmic floodgates. Suddenly, astronomers started spotting all kinds of strange, rule-breaking orbits. It's like the universe got tired of being predictable and decided to start a punk phase. You can almost imagine the star muttering, "I raised you better than this," as WASP-17b just keeps vibing backwards with zero apologies. Let's zoom out for a second. You're drifting through the cosmos, and you realize maybe everything we assumed about normal planetary behavior only applied to our tidy little neighborhood. Maybe the rest of the universe is out here doing interpretive dance while we were memorizing multiplication tables. We tend to think of space as ordered, stable, clockwork, but the truth, it's more like a reality show hosted by entropy. So, as you float just above the equator of this misfit planet, watching it trace its lazy reverse ellipse, you can feel something relax. There's something reassuring about broken rules in the middle of nowhere. If even the cosmos is this messy, maybe you're doing okay too. You close your eyes, the winds hush, the lights dim. Somewhere, backward gravity hums like a lullaby, and the rest of the galaxy keeps spinning mostly forward. Mostly quiet, except for this one rogue world doing its own thing. Section 2, you drift quietly now, the rebellious winds of WASP-17b fading into the cosmic distance behind you. The stars ahead seem calmer, steadier, like maybe the universe has sobered up a little. But then you notice something odd. A bright red star sits in the darkness, glowing with a bloated, ruddy intensity. At first it looks serene, even sleepy, but then something dark flickers across its surface, vanishes, and flickers again. You blink, and then you see it. The star is eating its planets. You're now approaching a red giant, an aging, swollen sun, nearing the end of its life. Picture it like the cosmic equivalent of a grumpy elder who's decided it's tired of hosting dinner and has instead started consuming the guests. Scientists still argue about how often stars devour their own planets, but this one leaves little to the imagination. Its official name is a bit forgettable, like something you'd find buried in a telescope catalog after 20 minutes of scrolling. But astronomers gave it the nickname BD Plows 48 740, which sounds like a printer model, but hides a cannibalistic secret. Here's the story. This red giant once had a solar system, possibly like ours. But as it aged, its core changed, swelling the outer layers until it ballooned in size hundreds of times bigger than before. In doing so, it engulfed at least one of its own inner planets, just slurped it up like a ravioli. We know this because of the chemical fingerprints left behind, specifically. An unusually high amount of lithium in the star's outer layers. Lithium burns away quickly in stars, so its presence suggests a recent infusion like, say, a snack-sized planet diving headfirst into nuclear plasma. And nearby, there's still a massive, surviving planet orbiting the star. A gas giant on a wildly stretched, elongated path like it's still flinching from what happened to its sibling. You watch this poor survivor arc slowly around the red monster, its orbit distorted into a cosmic ellipse so extreme it looks like a track drawn by a nervous toddler. You get the sense it knows it's next. Imagine the stress every few centuries. This giant planet swings dangerously close to the red star, just outside the kill zone. It's like cosmic Russian roulette, except instead of a bullet, it's being vaporized in an inferno. Meanwhile, the star keeps expanding. One day, it will grow large enough to eat this planet too, or it might die first, imploding into a white dwarf and leaving behind a graveyard of debris. Either way, the message is clear: the system has serious boundary issues. Now, for a quick definition, since we're talking red giants, a red giant is a star in the late phase of its life cycle. After burning through its hydrogen, the star begins to fuse helium in its core, causing it to swell and cool at the edges. It gets bigger, redder, and much, much hungrier. This isn't a rare event. Someday, our own sun will become a red giant. And yes, it will eat Mercury, then Venus, then maybe Earth. You can almost hear Earth whispering. But I recycled as it disappears into solar flames. We're not talking tomorrow, though. That's like 5 billion years from now. So you've got time to finish your taxes. There's a funny story about a simulation run by a team of European scientists who tried to model what would happen if a star ate a hot Jupiter-sized planet. The result, a temporary burst in brightness, strange wobbles in the star's surface, and the haunting possibility of burps. Yes, they described the energy spike as something like a stellar burp. That's where we're at with astronomy metaphors. Meanwhile, social media gurus still argue about whether astrology counts as science. Spoiler, the red giant doesn't care if Mercury is in retrograde. It is Mercury now. From your vantage point, the entire system looks eerie, peaceful on the surface, but underneath chaotic. This star is aging, yes, but not gracefully. It's one of those former champions who doesn't want to retire, just devour the whole locker room. And yet, there's a strange beauty to it. You float above the star and imagine the planets that used to orbit here. Small rocky worlds with atmospheres. Maybe one had oceans. Maybe one had cities. Maybe none did. But they're all gone now. Swallowed, digested, erased without ceremony. That's the thing about space, it doesn't do closure, just motion. So you drift onward, past the surviving planet still trying to escape, past the red glow that pulses with fading rage, and into the quiet once more. Stars aren't just lights in the sky. Sometimes they're graveyards. Sometimes they're predators. And sometimes they're both. You lean back into the dark, eyelids heavier now, imagining what it feels like to be a world on the edge of extinction but still holding on. The universe stretches outward, full of possibilities and probabilities, and occasionally, planets that don't know when to leave dinner. Section 3. The glow of the red giant fades into the distance behind you, like a bad dream retreating into the morning. You move forward now, deeper into the quiet, where fewer things make sense, and the rules of the universe start to feel more like guidelines. The next system doesn't pulse or roar, it glistens. At first, you think it's a trick of the starlight, a glint, a sparkle, a twinkle that won't stop winking. But then you drift closer, and there it is. A planet? Not just beautiful, unreasonably beautiful, shaped like a sphere. Spinning slowly, this lonely world orbits a dead star, and it gleams as if it's made of polished glass or... Wait, no, it's made of diamond. You're looking at PSR J1719 1438b, casually known as the Diamond Planet. This isn't poetic hyperbole. This thing is literally a crystallized chunk of carbon. Compressed under so much pressure, it turned into something so dense, it could make a millionaire weep. The planet orbits a pulsar, one of the strangest beasts in the stellar zoo. That pulsar is what's left of a collapsed star, a neutron star, spinning at ridiculous speeds, pulsing radio waves like a cosmic metronome. It rotates over 10,000 times per minute, and you can feel that beat out here in the dark like a low hum thrumming through your ribs. Now, the planet itself is about half the size of Jupiter, but far, far denser. It probably used to be a star, once a white dwarf, to be specific. But most of its mass got stripped away, and what's left is the bare, crystallized carbon core. Imagine a collapsed soul of a star. compressed and sharpened until it became a single faceted gem hanging in space. You might be tempted to think, cool, I'd like to visit. Don't. This planet isn't just sparkly, it's deadly. The surface gravity is high enough to flatten you into a pancake before your atoms had time to file a complaint. Still, it's easy to imagine galactic billionaires trying to mine it. A few years back, some PR genius actually calculated the planet's theoretical value, $27 nonillion. That's a 27 followed by 30 zeros. You'd need a spreadsheet powered by stars just to total it up. Social media types still argue about whether this counts as real wealth. Can a planet be rich if there's no one to buy it? And philosophers have a field day with it if a diamond planet exists in the void and no one can admire it. Is it still beautiful? Short answer, yes. Long answer, yes. But it's also terrifying. You float closer now. And even from space, you can feel it. A cold, radiant pressure, like standing too close to someone who doesn't blink. Its atmosphere is long gone, stripped away by its hungry pulsar neighbor. There's no weather, no erosion, just hard, timeless sparkle. Here's a fun side story. When astronomers first discovered this planet in 2011, they weren't looking for beauty. They were hunting down weird pulsars, and then someone noticed the wobble. Something massive and dense was orbiting close, tugging at the Neutron star like a clingy X. When they ran the numbers, their jaws collectively dropped. It wasn't just a dense object. It was a carbon-based planetary remnant, spinning close, compact, and impossibly rich. A literal diamond in the dark. The official term for it is ultra-low mass carbon planet, which sounds like a diet soda but describes a cosmic ghost. You're floating next to the corpse of a dead star that got crushed into jewelry. Take a second. Imagine the sound of it, not just the pulsar's beat, but the crackling silence of a world that can't decay. No tectonics, no wind, no water, just permanence. And isn't that what some humans crave? Something unchanging. Something valuable because it doesn't rust, or wrinkle, or cry. This planet laughs at that. It didn't choose immortality? It got abandoned into it. You watch the way its edges reflect light in slow, silent curves. You try to picture what it would be like to walk on it, but your imagination falls short. You're used to soft things, clouds, beaches, wet leaves. This is a world with no give. Even the pulsar next to it seems to ignore it. They're locked together in orbit, like divorced roommates who can't afford to move out. And you realize this system is a perfect metaphor for cosmic indifference. Something used to be alive here. A star that burned, a planet that formed, maybe moons and oceans and warmth. But now there's just a jewel and a ticking corpse, dancing forever in the cold. It's haunting. It's elegant. It's exactly what the universe would create if it didn't care whether you found it poetic or horrifying. And still, it glows. You lean back now, letting the planet shrink into a pinpoint behind you, like a diamond being dropped into velvet. The pulsar's rhythm fades. The light softens. Somewhere, back on Earth, people dream of treasure buried in caves or gold at the ends of rainbows. But you've seen something stranger, richer, lonelier. You close your eyes and let the dark sweep over you like a blanket. The pulse becomes a lullaby. The diamond turns and turns and keeps turning. Section 4, you're adrift again, leaving behind the frozen shimmer of the diamond planet. The void stretches around you like a vast, black ocean, calm on the surface, but always hiding something underneath. And then, just ahead, something moves. Not a gentle spin or a slow drift like most stars. No, this thing is flying. A full star system barreling through space at breakneck speed. You instinctively flinch, like it might sideswipe the cosmos and keep going. Welcome to the cosmic equivalent of a runaway train, the hypervelocity star system. You're looking at HIP 623 Phaedo, one of the fastest rogue stars ever recorded. And just like that friend from high school who left town suddenly and never came back, no one's quite sure what it's running from. HIP 623 Phaedo is traveling at over 2 million miles per hour. That's not hyperbole. That's fast enough to leave the Milky Way entirely and never look back. In cosmic terms, it's a full sprint into oblivion. Stars don't usually behave like this. They're gravitationally loyal. They stick to the dance of galaxies, orbiting around the center in predictable spirals. So when one decides to yeet itself across the void like it's got somewhere to be, scientists take notice. Here's a quick definition to tuck in. Your sleep-deprived pocket, a hypervelocity star, is a star that's moving so fast it can escape its galaxy's gravitational grip. Think of it as a cosmic escape artist, or maybe a mistake with momentum. HIP 603 Phaedo isn't just fast, it's dramatic. It has all the markings of a star that's been in a galactic bar fight. One theory suggests it was once part of a binary system. Its companion may have gone supernova, blasting HIP 603 Phaedo into high-speed exile like a slingshot from hell. Another theory, it got a little too cozy with the supermassive black hole at the center of the Milky Way. The kind of toxic relationship where one partner tears you apart and the other ends up flying out of the galaxy with trust issues. Scientists still argue about which scenario fits best, but the result is the same. This star system is done. It's out. Not just leaving its neighborhood, leaving the galaxy entirely. And the weirdest part, it might not be alone. We now think rogue system stars, planets. Maybe even whole clusters are drifting through intergalactic space, unseen. Homeless celestial nomads moving without an orbit, without a plan, and without any hope of turning back. You're floating near HIP 603 Phaedo now, watching the dust trail it leaves in its wake. It's subtle, but it's there, a faint line of disturbed particles, twisted by speed and heat. Any planets it once had are probably long gone, or they're still clinging on, white-knuckled and spinning like coins in a wind tunnel. Imagine living on a world like that, every night. The constellations would shift faster than you could memorize them. The sky would warp. Stars would stretch into strange lines as your solar system left behind everything it once knew. There's something weirdly human about it. The idea of fleeing danger, of going so fast that not even gravity can catch you. HIP 603 Phaedo didn't slow down to pack bags or say goodbye. It just left. And we're not even sure where it's going. Maybe nowhere, maybe everywhere. Here's a strange thought: in 500 million years or so, this star will be in another galaxy, one we can't even see yet. It'll arrive like a confused tourist with no local currency and a star map written in a dead dialect. A quick sidebar, there's a fun debate among sociologists and space nerds about whether humans are psychologically capable of processing this kind of speed. It's so outside our normal frame of reference that even imagining it gives people existential vertigo. Meanwhile, HIP 603 Phaedo just keeps flying. You let your body drift beside it, sensing its motion as a constant tug, not a breeze, but a direction. Even here, in the vacuum, you feel it. This isn't just momentum, it's intent. The star isn't falling, it's escaping. It makes you wonder if a star system can be flung so violently. What else out there is traveling alone? Is there a planet like Earth, wandering without a sun? Is there a galaxy where every star has a story, like this torn from home, never to return? And then you realize the system, with its reckless velocity and untraceable past, is more than a curiosity. It's a reminder. The universe doesn't play fair. It doesn't hand out stability as a birthright. Sometimes, things just get launched. And sometimes, that's the only reason we ever notice them. You turn back for a moment. The Milky Way is already far behind, a glowing bruise in the dark. Ahead, the void stretches unclaimed, uncurved, unexplored. HIP 6035 throws streaks into it like a needle through velvet. And you let it pass. You drift again, slow and soft. Let your limbs loosen. Let the silence wrap around you like sleep. Not everything fast is urgent. Some things just need to be far away. Section 5. The runaway star fades into the black behind you, leaving nothing but a faint ache in the direction it vanished. You're weightless now, spinning slowly, as if the universe hit pause. Then you hear it, not sound exactly, more like rhythm, a faint, steady thump. Then another. It pulses through the emptiness like a drumbeat muffled by light years. Ahead floats a star that doesn't burn or race. It breathes. You're approaching a variable star, more specifically, a Cepheid variable named Delta Cephei. These stars are the metronomes of the cosmos, expanding and contracting in rhythmic cycles so precise, astronomers use them as interstellar tape measures. And Delta Cephei, it's the original, the blueprint. The reason we can measure how far things are in space, here's the easy definition. A Cepheid variable is a star whose brightness changes in a regular pattern, swelling and dimming like it's inhaling and exhaling. The bigger the star, the slower the rhythm and the brighter it shines. Henrietta Leavitt figured this out in the early 1900s. No joke, she cracked the cosmic distance code with nothing but a notebook and patience. As you drift closer, you can see Delta Cephei pulsing gently, not violently, not like it's struggling. It's more like a heartbeat, a glow that swells with breath and shrinks again in a slow, golden rhythm. Every 5.5 days, it grows brighter, then dims, like it's alive. It's enormous, several times the size of the sun, but it doesn't roar like other giants. It whispers a kind of photonic sigh. You imagine what it might be like to orbit a star like this. Every week, the sky would brighten and fade. Days wouldn't just pass, they'd pulse. Time would feel less like a march and more like a slow dance. You float alongside it now, watching the star's outer layers balloon outward. It's not smooth, more like watching lava rise in slow motion, then cool, then rise again. It looks like it's breathing, but with the entire surface of a sun. Scientists still argue about why some stars pulse so perfectly. It has to do with helium ionization in the star's outer layers, creating a kind of heat trap, causing it to expand until it cools and collapses again, over and over. A stellar version of overcooked popcorn rhythm. There's a quiet elegance to it. Unlike the chaos of rogue stars or cannibalistic giants, this system feels meditative. You notice that Delta Cephei has a companion, another star. They orbit each other gently, like old friends who know each other's moods. That second star doesn't pulse, just watches, constant and supportive. Imagine that kind of cosmic relationship, one partner changing, shifting, flaring with light, and the other simply circling, steady and quiet. It's kind of romantic in a very long distance, mostly plasma sort of way. Here's something weird. Delta Cephei isn't just beautiful, it's useful. Because of its predictable rhythm, astronomers have used it as a cosmic yardstick to measure other galaxies. It's one of the reasons we even know how big the universe is. Before the star, The Milky Way might as well have been the whole universe. After it, we realized we were just one swirl in a sea of others, all because one star couldn't sit still. There's even a funny story, well, cosmic funny, about how the discovery of Cepheid variables helped Edwin Hubble prove that other galaxies existed. Without Henrietta Leavitt's work, we might still be arguing about whether Andromeda is part of our galaxy or just a fuzzy smudge on someone's telescope lens. It's wild to think that all of this came from one idea brightness that changes predictably means distance. Like if your bedroom light could help someone map the entire planet, you drift closer now. Just outside the star's atmosphere, where the temperature is slightly less horrifying. Here, in this quiet bubble of light and rhythm, it's easy to pretend everything is okay. Delta Cephei pulses again. It's subtle, but you feel it. The glow expands just a bit, and your whole body seems to rise with it, like you're floating on a tide you didn't know was there. And suddenly, you remember something very human: how we measure time. The ticking of a clock, the beat of a heart, the rhythm of breath. Here, far from Earth, a star does the same thing, on a scale too big to matter, and yet too precise to ignore. You're lulled by the predictability, the steady rise and fall, like a lullaby written in light. It makes you wonder how many other stars are out there, pulsing unseen, their light arriving thousands of years, too late for us to know if they're still breathing. You float beside the rhythm for a while, letting the light flicker across your skin in warm, silent waves. You could stay here for days and still not grow bored. There's something healing about a universe that, amid chaos, still builds in repetition. Eventually, you drift onward. The heartbeat fades behind you, but you carry its rhythm, a reminder that not everything strange is terrifying. Some things are just steady, quiet, reliable. You exhale with it. The light grows dim. You pulse once with the universe, and then you sleep. Section 6. The breathing star fades behind you like a lullaby settling into silence. You drift further now, through the velvet dark, waiting for something to surprise you, and it does. 2 suns rise on the horizon. At first, you think it's an illusion, but as you float closer, the truth becomes undeniable. This is a world with 2 stars, and it's doing its best to survive in the middle of them. Welcome to a real-life Tatooine, a planet orbiting a binary star system, where every sunrise comes in stereo. The technical term is a circumbinary planet, and the one you're approaching is called Kepler 6b. But that name doesn't do it justice. It should be called Desert Mirage World, or the planet that woke up too early. Because this thing is weirdly stable in a place where everything should be chaotic. You hover in orbit now, just above its pale, sandy surface. It's cold, surprisingly cold, despite having 2 suns. The stars here are small ones, a K-type dwarf, and the others an even dimmer red dwarf. Together, they're like 2 lanterns that never quite agree on how bright the room should be. Imagine standing on the surface. The light changes constantly. Sometimes you get a long, warm sunset. Sometimes the stars eclipse each other, and you're plunged into shadow at high noon. Some days, it's like the sky can't make up its mind. It's beautiful, and also utterly bonkers. Here's a quick definition. A circumbinary planet is one that orbits 2 stars instead of 1. Think of it like a child, with 2 parents doing an awkward dance, and the child's just trying to make it to bedtime without vomiting. Scientists still argue about how these planets manage to form at all. In most simulations, the gravity of 2 suns should cause so much turbulence that planets either never form or get flung away like popcorn in a jet engine. But Kepler 16b exists, Calm, predictable, even a little smug. You drift lower through the thin upper atmosphere. There's no life here, not that we know of. The temperature hovers around minus 100 degrees Celsius, but the terrain is oddly smooth. Wide plains, frozen dunes. It's the kind of planet that seems designed for quiet thoughts and dramatic solo walks. There's a weird elegance to its orbit. Kepler 16b completes one lap around its two suns every 229 days. The stars, in turn, orbit each other every 41 days. It's a gravitational waltz, and somehow, everyone keeps their footing. Astronomers call it a dynamically stable configuration, which sounds like a corporate buzzword, but basically means it shouldn't fall apart. Yet, here's a fun fact. When Kepler 16b was discovered in 2011, it became the first confirmed planet orbiting two stars. Before that, it was mostly sci-fi fantasy. The moment it was confirmed, half the scientific community raised their eyebrows, and the other half squealed. Tatooine is real. One scientist even joked that George Lucas deserved co-author credit. You float over the Terminator line, the boundary between day and night, and you can see how different the sky looks from moment to moment. In some places, shadows are double-layered. In others, they cancel each other out. Every sunset paints the ground with overlapping halos of orange and red, and a weird shade of teal you didn't think light could make. The planet isn't just stable, it's quiet. There's no tectonic activity, no storms, no magnetic tantrums. It just spins, obediently, like a student who knows it's being graded. It makes you think about balance. On Earth, balance is hard. Work life, logic emotion, snacks health. But here, in the middle of cosmic chaos, this little frozen world figured out how to dance between two competing forces and not fall over. It reminds you of that friend who somehow kept it together through 2 divorces and 3 job changes and still showed up to yoga class on time. There's a soft kind of strength in that. Scientists still wonder whether a planet like this could support life. Maybe not here. On Kepler 16b, it's too cold, too dry. But what about a warmer version with a thicker atmosphere? Could a double sun world grow forests, build civilizations, develop myths about twin gods fighting in the sky? You imagine it now, a culture built around the timing of eclipses, festivals held when both suns rise together, fables of lovers who became stars and now chase each other forever. And maybe, just maybe, there's a version of this planet somewhere else where someone is looking up at their double shadow and whispering the same questions you are. You hover now, just outside the planet's gravitational pull, letting the glow of 2 suns bathe your face. The warmth is faint, but real. Like sitting between 2 fireplaces, neither close enough to burn, both far enough to admire. This system doesn't defy physics. It just uses all the rules in surprising ways. As you drift away, the twin stars begin to eclipse each other, slowly, elegantly. The planet falls into partial shadow, and the desert below turns from amber to deep violet. You watch the last light fold across the horizon, and then you close your eyes. 1 sun, then 2, then none. You don't even notice sleep beginning. Section 7, darkness folds around you, soft and weightless, until the next star finds you. At first glance, it looks like any other small, dim, and spinning too fast, like it's nervous about something. But then you check the numbers, and they don't add up. You're now drifting near PSR J08 P31, a neutron star, quiet and humming with ancient energy. It's not the size that's strange, or the spin, or even the fact that it's a collapsed core of a long-dead star, barely 12 miles wide yet heavier than the sun. It's the age. The star is older than the galaxy it's in. You tilt your head, check your instruments, squint, but no, there it is. This neutron star's estimated age is over 200 million years older than the Milky Way itself, which is sort of like discovering your grandmother invented the town she was born in. Scientists still argue about what this means. Some claim the star's distance is off. Others suspect its spin-down rate has been misunderstood. A few, more romantically, whisper, what if it traveled here from somewhere else? Here's a quick definition. A neutron star is the leftover core of a massive star that exploded in a supernova. It's made almost entirely of neutrons, packed so tightly that a teaspoon would weigh more than Mount Everest. And PSR J018-UR31 isn't just a neutron star, it's a pulsar, beaming regular radio signals out into space like a cosmic lighthouse, but its signals are weak now, fading, which makes sense, given it's supposedly billions of years old. You hover just outside its magnetosphere, where radiation doesn't bite quite so hard. The star spins slowly now, like an old music box winding down. You can almost hear the rhythm, a click, a pause, a flicker, then silence. And yet it's still here, which begs the question, how one theory is that the pulsar didn't actually form where it is now. It could have been born in another galaxy, perhaps a dwarf galaxy swallowed by the Milky Way and carried in like luggage through a cosmic merger. Imagine showing up at a party 200 million years before the house was built. You float there, staring at this object that refuses to be explained. The universe is full of paradoxes, black holes, dark energy, microwave background radiation, but there's something uniquely unsettling about an impossible age. Like it's not just surviving time, it's dodging it. There's a weird story from 2008 when astronomers at Swinburne University used a particularly sensitive radio telescope to locate this star's precise position. It was fainter than expected, weaker, but somehow still pulsing. It was like finding a candle still flickering in a house that had burned down billions of years ago. And it makes you wonder, what would a traveler that old remember? PSR J008-1231 has seen galaxies collide, stars born and buried, planets form and melt. If this thing could talk, it wouldn't use words. It would just vibrate with memory. You drift a little closer. The star's surface is invisible, not really, but your mind paints the picture. A scorched metallic crust, cracks spidering out from its magnetic poles, an iron skeleton holding together by sheer gravitational spite. You think of all the young stars blazing arrogantly across the galaxy, burning through fuel like toddlers with glitter. And here's this ancient husk, still turning, still sending signals into the dark. It makes you respect stillness in a new way. Scientists don't like mysteries like this. There's a quiet discomfort in knowing the math might be wrong, or worse, the math is right. And this thing just shouldn't be here. You let that unease settle, not in a scary way, in a reorienting way, because sometimes the universe throws you a glitch. A gentle one, a question mark that just floats there, offering no answers and no pressure to find one. You feel the faint pulse of the neutron star echo through your bones. Not painful, just present. Like the tick of a grandfather clock in the next room. It doesn't demand your attention. It just exists. You close your eyes for a moment and imagine drifting through space at the speed of nothing, letting billions of years pass. Not resisting decay, not fearing silence, just being. A star like this doesn't need to shine to matter. It doesn't need an audience. It's the definition of endurance, a cosmic middle finger to entropy. You float back now, leaving the ancient object behind. It doesn't fade, it just grows smaller, A quiet dot blinking with impossible age, and in your mind, the question still lingers. How can something be older than the stage it's standing on? Maybe that's not a paradox. Maybe it's just proof that the universe keeps secrets better than we do. Section 8. You float now through a corridor of stars that feel right. Predictable, comforting, even. Their orbits make sense. Their temperatures match expectations. You almost relax. And then you see it. A scorched world. Blackened, scarred, clearly ruined, but not gone. This is K2141b, a planet that by all logic should not still exist. Imagine a world where the surface is lava, where the sky is ash, where it rains rocks, and yet this hellscape continues to orbit its host star like it hasn't read its own obituary. You approach slowly, drawn toward its smoldering silhouette. K2141b is so close to its star that a year, one full orbit lasts just 7 hours. Not days, hours. You could fly here in the morning, orbit it by lunch, and be late for dinner somewhere cooler. Here's your easy definition. K2141b is a lava planet, a type of rocky exoplanet that orbits so closely to its star. The surface has literally melted. Not just lava lakes, not just volcanoes. The entire hemisphere facing its sun is an ocean of molten rock. It shouldn't last. And yet, it does. Scientists still argue about how this planet hasn't been obliterated by its star. It should have vaporized. It should have collapsed into slag and plasma and been flung apart. But instead, it just keeps cooking. You hover over the day side. The heat here is unimaginable, over 5,000 degrees Fahrenheit. That's hot enough to vaporize most metals. The atmosphere, if you can call it that, is more of a rock vapor plasma swirl. It's not breathable. It's barely survivable for rock. Then you drift to the night side, and here, the story changes. The far side of K2141b is freezing, dark, almost calm. Temperatures drop to minus 300 degrees Fahrenheit. Lava turns to brittle rock. The storm winds that carry vaporized minerals from the day side scream across the Terminator line and rain rocks down in solid form? That's right on this planet. Weather is a rock cycle. Like water evaporating, condensing, and falling back as rain, except here, it's stone. It literally rains rock. Imagine walking outside and needing an umbrella made of steel, and also needing to run, because the ground is lava and the atmosphere is shards. It's chaos. It's poetic. It's still somehow functioning. There's a term used in exoplanet studies, lava world thermal balance. It describes how heat distribution, despite being ridiculous, can reach equilibrium. On K2141b, the hellfire on one side and the icy vacuum on the other keep each other in check, like a cosmic oven with one door open. You watch, amazed, as supersonic winds over 3,000 miles per hour carry molten vapor from one hemisphere to the other. And yet, the planet does not explode. It does not lose mass at the rate you'd expect. It just sizzles quietly. In 2020, a group of researchers ran simulations showing that these types of rock cycles could go on for billions of years. That's right, this planet might still be doing this long after our species forgets what lava is. There's a dark kind of resilience in that. You hover at a safe distance, watching the night side's rocky rain fall silently into an ocean of cooling magma. You imagine the sound of its stone hissing as it touches molten ground, steam and mineral dust spiraling upward into nothing. It's easy to think of this place as a failure, a world that never had a chance. But what if it's a survivor? What if this is what endurance looks like in the extreme? You think back to Earth, to places we once called uninhabitable deserts, volcanoes, Arctic ice shelves and how life still found a way to show up, whispered challenge accepted, and evolve. No, there's no life here. But K21.1b doesn't need to be alive to be determined. The surface is smooth in places, etched with strange patterns, the result of cooling flows and microstorms. Other regions are cracked like shattered glass, each fracture a history of thermal rage. And still, it spins, still, it orbits, like a grizzled boxer, staggering back into the ring because gravity hasn't counted it out yet. You drift farther back now, letting the gravity of this death world release you. The glow of the lava fades into a smudge behind you, and for a moment, you see it not as a horror, but as a light, a stubborn flicker in a sky full of elegant burnouts. Scientists love order, but this planet isn't here to be understood. It's here to remind you that sometimes survival isn't pretty. It's just heat, pressure, and not giving up. And that's kind of inspiring. Even if you're just made of stardust, floating in pajamas. Section 9, you leave the lava world behind. Your senses still echoing with the heat, the hiss, the stubborn refusal of that planet to accept its fate. This next place is quieter. Too quiet. Ahead of you lies a patch of space where something should be. All the maps say so. Every telescope pointed here agrees there was a massive star, a true monster. Thousands of times brighter than our sun. And then, one day, it just disappeared. No explosion, no collapse, no trail of debris. You're approaching the vanishing star, officially known as N6946BH1. It once burned at the edge of the fireworks galaxy NGC 6946, a place known for frequent supernovas, as if the entire region were permanently celebrating its own destruction. But not this time. N6946BH1 was a red supergiant. Big, loud, dramatic. The kind of star you'd expect to go out in a blaze of glory, a supernova that would light up the sky for weeks. Astronomers watched it grow brighter in Twilight 9. They got ready for fireworks, and then it went dim, faded, gone. Here's the quick definition. A failed supernova is what might happen when a massive star collapses directly into a black hole without the typical explosion. Like someone pressing delete on a skyscraper and leaving no dust behind. Scientists still argue about what actually happened. Maybe it did explode, but the blast was hidden behind a cloud of dust. Maybe it collapsed so fast, nothing had time to scatter. Maybe it's still there, but in a form we don't yet know how to see. Whatever the truth is, the result remains a missing star. Imagine standing in a field where a lighthouse used to be one that guided your path, blinked reliably for centuries, and now there's just fog. The light didn't break, it didn't flicker, it just ceased. You're floating above the place it used to be now, not over a planet, or a nebula, or even debris, just space. Some astronomers think what we're seeing here is a direct collapse into a black hole, a rare, quiet process where gravity wins so thoroughly that not even photons escape. It's not a bang, it's a whimper. Swallowed mid-sentence. A 2015 study led by a team using the Hubble and Spitzer telescopes confirmed it. The star's brightness dropped by a factor of 1,000. Follow-up observations. Still dark, as if someone turned off the cosmic porch light and walked away forever. There's no epic explosion, no cosmic autopsy, just absence. And that absence is louder than any blast. You drift slowly in the emptiness, trying to picture what was here. A red supergiant the size of 30 suns. Layers of hydrogen and helium stacked like glowing lasagna. The star would have roared with convection currents the size of continents. And now, not even a whisper. It's funny, humans often expect endings to be dramatic, but the universe reminds us some of the biggest transitions happen silently. You think back to old stories, dying kings, fallen empires, lost cities, and you realize this star has joined them. A celestial Atlantis, a monument to what was. You drift a little farther, staring into the dark where light should be. There's no pull, no obvious black hole tugging at your limbs. It's just still, and that's maybe the creepiest part. It's like the star left behind a question. Not where did I go, but were you even paying attention? You consider how many stars are out there, billions upon billions, and how many might vanish without notice. How many might collapse inward, unnoticed, becoming scars on the sky. There's a metaphor in there. Something about people, about fading without a scene. But your mind is too soft now to hold on to it. The silence here is heavy, but not hostile. More like a library. You feel the weight of something huge, something final, that used to be here, and then you notice something. A faint gravitational lensing, a subtle distortion in the background light. The only clue that something massive still lurks where the star once was. A shadow with gravity. A ghost you can't see but can still feel. You float there for a moment longer, the hum of your thoughts aligning with the hum of space. There are no explosions here, no colors, no orbits. Just a message written in negative space. Sometimes, what's missing is more important than what's there. And with that, you drift on. Section 10. You coast away from the place where a star once was, letting the weight of its silence settle into your bones. Somewhere behind you, gravity keeps folding the dark like an invisible hand. But ahead, motion. Not normal motion, something else. Something tangled. You've arrived at the scene of a cosmic ballet that refuses to follow the rules. Welcome to a three-body system. A place where a planet doesn't orbit so much as it loops, dances, whirls through space in a pattern so chaotic, even physics throws up its hands and says, honestly, just do your thing. The system you're approaching is called KOI-5, and it's an orbital mess. One star would have been complicated enough, but this place, 3 stars, 1 planet, and 0 chill. Here's your quick definition. The three-body problem is a famous dilemma in physics and mathematics that refers to the unpredictable motion that arises when 3 celestial bodies interact gravitationally. There's no simple solution. The more you calculate, the more you realize the math doesn't settle. It dances. The planet in KOI-5 orbits 1 star, but that star is orbiting another star, which is itself in a dance with a third. And this poor planet, KOI-5ab, is stuck in the middle like a kid in a very dysfunctional family road trip. You float in now, watching it happen. The planet's path curves, then wobbles, then curves again, not a circle, not an ellipse, more like a cosmic doodle. If you tried to map its orbit, it would look like a toddler scribbled with a crayon while spinning in a chair. And somehow, it's still there, still orbiting, still hanging on. Scientists still argue about how this system formed. Some believe the planet came first and the extra stars moved in later, like rowdy neighbors. Others think all 3 stars formed together, and the planet just happened to survive the gravitational chaos. Either way, it's like building a sandcastle during a hurricane and somehow ending up with a penthouse. A few astronomers call systems like these gravitationally unstable, which is the politest way of saying this thing is one bad day away from orbital spaghetti. KOI-5ab was actually discovered early in the Kepler mission, but was initially ignored because the system seemed too complicated, too weird, too annoying to model, like a math student who just draws question marks on their test and walks out. But then scientists circled back, ran the numbers again, and realized, holy crap, this planet is actually doing it. Surviving, even thriving with a highly tilted orbit, warped by the chaos of its sibling stars. It's like watching a figure skater perform a perfect routine on melting ice while dodging flying bowling balls. You hover close, now, watching one of the stars sweep by. It's bright, sharp, impatient. The second one lags behind, glowing redder and slower, like it's constantly 2 steps late to its own birthday. And the third, it's far off, dim, orbiting the whole mess like a disapproving aunt. And in the middle of all this, the planet, KOI 5 abs, spinning like a marble in a dryer. You try to imagine what the sky would look like from its surface. It would never be the same twice. Some nights, you'd see 2 suns fighting for attention. Other nights, a third star would rise from a strange angle, casting shadows you didn't even know were possible. And sometimes, nothing would show up at all, just darkness, waiting. It would be beautiful and exhausting. There's a strange comfort in watching it all play out. This isn't neat, it's not stable, but it works somehow. Like a family that argues constantly but still shows up for each other's birthdays. The orbits are chaotic, but they don't collapse. They just adjust, constantly. The planet shifts its path ever so slightly each time it rounds its primary. A nudge here, a pull there, and then it loops again, like a celestial jazz solo. A fun note, the 3-body problem has inspired not only astronomers, but also writers, philosophers, and more than one frustrated game designer. It's chaos theory in action. It's where order ends and improvisation begins. And here it is, playing out in real time before your eyes. You drift higher now, taking in the full system. The stars carve their own ellipses, while the planet loops around one and flirts with the gravity of the others. It doesn't follow a formula. It follows a flow. You think about the rules we cling to Newton's laws, Kepler's harmonies, even the comforting predictability of sunrise and sunset. And then you watch the system and realize sometimes the universe doesn't care about neatness. Sometimes it just wants to juggle, and somehow that's not terrifying. It's kind of hopeful, because if a planet can survive 3 competing gravitational pulls and still show up to orbit on time, maybe you can too. You feel sleep pulling at you now, soft and insistent, not unlike those stars. Each one tugging gently, trying to pull your mind out of orbit. You give in, let the system loop, let your thoughts spin like planets. Let the chaos be beautiful. Section 11, you slowly drift out of the gravitational maze behind you, letting the looping dance of the 3-body system fade into the background. Your brain feels looser now, like it's been softened by all that orbital jazz. But your next destination isn't wild. It's heavy, uncomfortably so. You're approaching HD 106906b, a planet that seems like it missed its true calling. It's massive, lonely, and honestly, kind of sulking. Why? Because this planet is so big, it almost became a star, but didn't, and now it just orbits. Way out on the fringe of its system, like the black sheep of a very awkward family reunion. Here's your simple definition. HD 106906b is a super Jupiter, an exoplanet over 11 times the mass of Jupiter, orbiting a pair of stars at an extreme distance around 730 times farther from its stars than Earth is from the Sun. Imagine Pluto. Now go way farther. Then multiply your sense of rejection by about 100. You float up to it now, and it's moody. This planet isn't close to its star. It's not even pretending to be part of the group chat. It's lurking out in the cold. barely bound by gravity, like it's considering whether to leave the whole star system behind and become a rogue. It's too big to be normal, but too small to ignite fusion and become a brown dwarf, those failed stars that glow faintly with leftover heat. HD 106906b doesn't glow. It absorbs. If planets had personalities, this one would be wearing sunglasses at night, leaning against the wall, listening to deep space jazz, and sighing a lot. Scientists still argue about how it even got here. Some suggest it formed close to its stars and was violently flung outward like it said something rude at a dinner party and got launched 730 astronomical units away. Others think it formed in isolation, then got captured later like a space drifter hitching a ride. Neither theory is completely satisfying. This planet is a puzzle piece that doesn't quite fit into any cosmic jigsaw. It makes astronomers uncomfortable, which is saying something. You watch it rotate now, slowly, like it's bored. Its atmosphere is likely thick with gas and dust. Deep storms churn across its surface in silence. No sunlight reaches it in any meaningful way. It doesn't care. It wasn't asking for your approval. The parent stars, HD, Tauhen 6906A and B, are far away now. They're young, bright, and chaotic themselves, a binary duo surrounded by a massive debris disk. They seem oblivious to their oversized planetary outcast. You imagine what it might feel like to live here. You wouldn't see your stars most nights, maybe not at all. The sky would be filled with darkness and the occasional confused comet who wandered too far. But there's something majestic about the distance. This planet isn't broken, it's independent, operating on its own timetable, no tidal locking, no dramatic eclipses, just long, slow orbits through the far reaches of its system. And yet, it's still bound, barely held by the faint tug of gravity. A reminder that no matter how far you go, something may still be reaching for you. Here's a fun twist: this planet was imaged directly, not inferred, not guessed at, seen by a telescope, invisible light. That's rare. That's like spotting a firefly on the other side of a stadium. In a blackout, while blindfolded. When the image was first released, some scientists actually thought it was a mistake. Too far, too massive, too weird. But the planet persisted, quietly, coldly, orbiting at its own pace. It's funny, people often talk about stars that failed to ignite, but no one talks about planets that got too ambitious. This one tried to cross the line, almost reached the threshold to burn, and got stuck in between. And maybe that's what makes it fascinating. It exists in a cosmic gray zone. Not a planet, not a star, just there, heavy, lonesome, determined. You float beside it for a moment longer. There's no light show, no lava, no strange orbit loops, just mass, gravity, presence. It doesn't want your attention, but it has it. And you feel a strange empathy. Not everything weird has to be dramatic. Some things are just other, and they survive anyway. Maybe you know someone like that. Maybe you are someone like that. And maybe that's okay. You drift backward now, letting the great dark sphere shrink behind you. The binary stars glimmer faintly, like distant memories. And HD 106906b continues its lonely, too-wide orbit, taking its time, not caring if it's late. Not every star is born, and not every planet plays by the rules. Some just exist, and that's enough. Section 12. The lonely giant fades behind you, swallowed by the interstellar dark, and for a moment it feels like the universe has quieted again until you catch a flash of sapphire on the edge of your vision. You turn, and there it is. HD 189733b. A world so violently beautiful, it shouldn't exist without a soundtrack. This planet looks like someone dipped Neptune in neon, then fed it an energy drink and dared it to become the most hostile thing in the galaxy. This is the world where it rains glass sideways. You heard that right. A planet where shards of silicate glass slice through the air at over 5,000 miles per hour, driven by jet streams so intense they make Earth's hurricanes look like polite breezes. You hover closer now, orbiting just above the Terminator line, the boundary between the planet's eternal day and endless night. HD 189733b is a hot Jupiter, a gas giant like Jupiter, but parked so close to its star that it's being cooked alive. Its year lasts just 2.2 Earth days. That's how fast it zips around its sun. But the weirdness doesn't stop there. Here's your quick definition. A hot Jupiter is a type of exoplanet that's similar in size to Jupiter, but orbits much closer to its parent star, often resulting in extreme temperatures, tidal locking, and bizarre atmospheric behavior. And HD 189733b. It's the poster child for atmospheric chaos. Its striking blue color, visible even in optical light, is not due to oceans or a clear sky. It's due to silicate particles in its atmosphere scattering blue light, just like Earth's sky does. Except here, the sky wants to murder you. As you drift over the dayside, you watch towering clouds of vaporized rock swirl into high-altitude storms. Temperatures reach nearly 1700 degrees Fahrenheit, hot enough to melt metal. There is no surface, just layers of toxic gas, pressured like a dying scream trapped in a bottle. And then, the winds. You can't see them, not directly, but you can feel the turbulence in your path. Massive equatorial jet streams move at Mach 7, ripping across the planet's face, carrying glass particles along with them. Not flakes, not dust, shards. They fly sideways, 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 always eastward, always slicing. You think about what that would sound like? Wind screeching with such force that even molecules scream. Imagine standing there hypothetically and hearing a million tiny razors howling across a planet that forgot how to be kind. Astronomers still argue about how these conditions came to be. The prevailing idea is that the planet's tight orbit, tidally locked, so one side always faces its star, creates a permanent day side and night side. That imbalance triggers thermal winds of terrifying intensity. It's a planetary pressure cooker, and the lid is vibrating. The heat expands the atmosphere so much that it leaks into space. That's right. HD 189733b is bleeding. Slowly, quietly, drifting molecules trail behind it like a vaporous tail. A ghost of its former self dissolving into the void. And here's the fun twist, this planet was one of the first whose weather was directly measured. In 2007, scientists used the Spitzer Space Telescope to observe its temperature changes as it orbited, effectively giving us our first weather map of an alien world. The weather forecast glass storms, all week, with a slight chance of death. You hover now at the edge of the night side. It's colder here, still unlivable, but calmer. The blue hue fades into deep navy. No sunlight reaches this region, and the winds wrap around, howling into the darkness, like the planet is trying to outrun itself. There's something poetic about it, a world torn between light and shadow, torn by its own orbit, its own heat, its own furious atmosphere, and yet it stays together, sort of. You let your mind wander. What if there were creatures here, not living in the atmosphere? Nothing survives this but above it. Maybe something that feeds on storm energy, or rides the jet stream like a surfer with no fear of splinters. It's ridiculous, but you imagine it anyway. You imagine a consciousness built for chaos, born into speed, seeing beauty in every shard of glass, Maybe that's what this planet is. Not a failed version of Earth, not a hellscape, a performance, an atmospheric symphony played too loudly, too fast, in a key no one understands. You float farther now, watching the blue firestorm shrink behind you. It's mesmerizing. A world that gleams like a jewel, but spins like a knife. It reminds you of someone with a dazzling smile and too many secrets. You can't live here, but you can admire it. Because sometimes beauty isn't soft, sometimes it's sharp. Sometimes it slices sideways through the dark and dares you to follow. Section 13. You let the razor winds of HD 89733B fade into the abyss behind you. The blue chaos softens to memory. Your path bends now toward something quieter. At least, at first, there's a flicker in the dark, then another, then nothing. You move closer, and suddenly light. A blinding, rhythmic pulse. Like a cosmic strobe light with something to prove. This is KIC 8462852, better known as Tabby's star. It blinks, it flares, it dims, and no one knows why. You may have heard of it. It broke the internet in 2015. Headlines buzzed with phrases like alien, megastructure, and the most mysterious star in the galaxy. And while the aliens are probably not involved, the mystery hasn't gone anywhere. You watch as it pulses again, and then, like a magician's trick, it disappears. Not entirely, just noticeably. As if something massive passed in front of it. Something irregular, not a planet, not a comet. Something more complicated. Here's your quick definition. Tabby's star is an F-type main sequence star about 1/4 light years away. What makes it bizarre is that it undergoes unpredictable, non-periodic drops in brightness, sometimes up to 22%. That's huge. Too huge to explain by a passing planet. You hover now near its corona, watching flares ripple out like lazy tidal waves. The dips in light are impossible to predict. Sometimes the star dims over days, sometimes over weeks, sometimes just for an instant, as if it flinched. Scientists still argue about what's causing it. Comets? Maybe, but you'd need a fleet of them. Thousands deep, lined up just right. Not impossible, but also not likely. A dusty disk, sort of, but there's no significant infrared signature, the usual giveaway that dust is present and glowing. A collapsing planetary system could be, but the patterns don't match what we'd expect. And yes, there was that theory, Dyson spheres, structures built by an advanced civilization to harvest stellar energy. Giant megastructures orbiting the star, intermittently blocking its light. No evidence supports it, but no one's entirely ruled it out either. It was a fun thought experiment that spiraled into wild speculation. Reddit theories, and very hopeful tweets, even today. We still don't know what's causing Tabby's flickers. You watch it now, up close. It's not flashing violently, just fading slowly, like someone dimming the universe's mood lighting. Then it brightens again, shyly, as if embarrassed to be noticed. There's something human about it. A star that can't decide whether it wants to shine. You drift just above its photosphere, far enough not to roast, close enough to see the roiling gases beneath the surface. It doesn't look different, not on the outside, but you know something strange is happening deeper in its core or around it. It pulses again. Imagine living in a system like this. Every few weeks your skies darken, not with clouds, not with night, but with something huge and silent moving across the heavens. Maybe your culture would build stories around it. Gods closing their eyes, sky beasts swimming past, a planet-wide sigh, a cosmic warning. Or maybe you'd just learn to live with it? Blinking skies, uncertain light, A weather pattern not of wind or temperature, but of clarity. There's a strange elegance in that. You recall a story from Tabitha Boyajian, the astronomer who led the team that first documented the star's strange behavior. She once said that she thought it was a data error at first, just bad input, because it didn't make sense. No other star behaved this way. But it was real, and so began the obsession. Thousands of amateur astronomers joined in, watching, recording, waiting for the next dip. People started calling it the most observed star in the sky. And yet, nothing concrete has emerged. Tabby's star is either hiding something or being honest about how messy stars really are. You float a little farther back, watching it pulse again, a gentle blink, a flirtation with darkness. You realize we don't always need answers. Sometimes the question is the show. You think of all the mysterious people you've known, the friends who vanished from your life without reason, the ones who sent strange texts at 3 a.m., the teachers who paused mid-lecture like they remembered a secret, not broken, just flickering, like Tabby's star. You close your eyes, the light fades, but not all the way. It's still there, behind your lids, blinking a rhythm you can't quite decode. You let it fade again. You don't need to understand it. You just need to let it glow. Section 14. The blinking star recedes, still pulsing gently behind you like the heartbeat of a shy idea. You coast now into the true, dark, the space between stars. No blinking, no swirling, just absence. And then you see it. One star, just one. Not part of a system, not orbited by planets, not gravitationally tied to anything, just alone. This is a rogue star, and it has no home. It's called SDSS J129 plus 172927, but names don't matter out here. What matters is that this star is floating, completely untethered, in the middle of nothing. It's the stellar equivalent of a hiker who wandered off trail and never looked back. You drift closer, watching it shimmer faintly in the deep black. It's a small, barely 80% the mass of the sun and dim, like it's trying not to be noticed. You'd miss it if you weren't looking for it. Most people do. This is what's known as a population 2 star, one of the oldest types in the universe. Its atmosphere is nearly devoid of heavy elements. No iron, no carbon, almost no lithium. It was formed when the universe was young, before those elements even had time to appear. It's a star made almost entirely of hydrogen and helium, a primordial survivor. And somehow, it got here. Not orbiting a galaxy core, not hanging out in a binary, just out in the cold, drifting through interstellar space like an old sailor who forgot what a harbor is. Here's your simple definition. A rogue star is a star that has been ejected from its galaxy or never formed in one at all. Unlike the more famous rogue planets, which wander without stars, these are stars without homes. Their gravity isn't holding anything. Their orbit is meaningless. They just drift. Scientists still argue about how many of these stars exist. Some say billions, others say trillions, but no one can find them all. They're dim, they're distant, and they're not tied to anything that makes them easy to spot. But SDSS J12915 plus 72927. This one was noticed, and it broke some hearts when it did, because of what it lacks. Most stars formed after a few generations of supernovae, after heavier elements, what astronomers call metals. Even if it's just carbon, had seeded the gas clouds. But this star, it was formed from the untouched universe. Its metallicity is so low, it's practically a fossil. It's not just homeless, it's ancient. You float beside it now, and it doesn't burn hot. It glows a pale, cool, white content. In in a way that only a star with no expectations can be. It's not supporting life. It's not pulling planets. It's not part of a binary drama. It just exists. Quietly. There's no wind out here. No echoes. Just the endless drift. You imagine being a sentient observer on this star. A tiny life form clinging to some orbiting rock, staring out at the void and never seeing another sun. No constellations, no neighbors, just your one star. You'd probably invent myths about your sun being the sun. The only one? And you wouldn't even be wrong, because this is all there is. There's a story astronomers tell about stars like this, how they might be relics from galaxies that no longer exist, ejected during galactic collisions, spat out from failed mergers, survivors of violence older than Earth itself. This star might have been part of something once, a galaxy, this cluster, a system, but now, just memory in motion. And yet, it shines, barely, but it shines. It's a soft kind of defiance. No audience, no orbit, no structure, just thermonuclear fusion, humming along out of sheer cosmic habit. It makes you think of those people you see in all-night diners at 3 a.m., reading a paperback, drinking cold coffee. No one's watching them. But they're still being... That's the star. A cosmic diner light left on in the middle of nowhere. You float a little farther out, and something strange happens. The silence gets louder. You realize how quiet the galaxy actually is. Stars usually chatter, gravitationally pulling, pushing, syncing their rhythms. But not here. This star is alone, and it likes it that way. You begin to feel something settle inside you. Not loneliness, exactly not sadness. Something else. Stillness. A reminder that not everything that drifts is lost. That detachment isn't always a tragedy. Sometimes, it's just another kind of truth. You let that thought hold you. Let it stretch out. You let yourself drift too. With nothing to pull you back. No rules. No orbit. No reason. Just quiet. Section 15. You've left the loner star behind. Its soft glow swallowed up by distance until even memory struggles to hold on to it. You drift onward. Slower now. Deeper into the dark. And then, impossibly, you see it? A galaxy. Not just a dot. Not a smudge. A full, spinning structure of light arms spiraling out like a dancer mid-twirl. But something is wrong. It shouldn't be here. Not yet. You're looking at GN's 11, a galaxy so far away and so old that it forces the universe to rethink its own timeline. Here's your simple definition. GN's 11 is the most distant and oldest known galaxy, forming just 400 million years after the Big Bang. That may sound like a lot, but cosmically, it's barely enough time to microwave a pizza. This galaxy, by all accounts, is too early. Galaxies weren't supposed to form this quickly. Not this big. Not this bright. And yet, here it is. Spinning, forming stars, breaking the rules. You float closer, not literally, of course. GN's 11 is 13.4 billion light years away. You're seeing it as it was back then. Before Earth. Before the sun. Before even most atoms had decided what kind of universe this was going to be. And this baby galaxy, it looked around, shrugged, and said, "I'm ready." Scientists still argue about how something so complex could form so early. Galaxies take time. First, hydrogen collapses into stars. Then stars die, seeding space with heavier elements. Then gravity herds everything into swirling patterns. That's how it's supposed to go. But GN's 11 skipped ahead. It has structure. It has mass. It's forming stars at 20 times the rate of the Milky Way. It's the kid who showed up to kindergarten already doing algebra and asking for the manager. You watch it now, hanging at the edge of observable space. There's something about it that feels unfinished. Not in a bad way. In an eager way, like it's still figuring itself out. But it's not waiting for permission. The light you're seeing left this galaxy 13.4 billion years ago, before our sun was a glimmer in a gas cloud's eye, before Earth cooled, before dinosaurs, before bacteria, before time had settled down, and yet that light is just reaching your eyes now. The delay is staggering. You're not looking at the galaxy as it is, you're looking at it as it was, back when the entire universe was still warm from its own birth. And that thought, it humbles you. You imagine what it must have been like inside GNZ11 during its youth. Stars forming, exploding, reforming. Gas clouds crashing into one another like soft-boiled galaxies in training. A whole little cosmos. Unaware it was being watched billions of years later by a sleepy human floating through the bedtime thoughts. Astronomers used the Hubble Space Telescope to spot it, barely a speck in deep field imagery. Later, JWST confirmed its distance, and with it, the panic. Wait, galaxies aren't supposed to be there yet. It's like finding a skyscraper in the middle of a forest that hasn't even finished growing trees. Either we're wrong about how galaxies form, or GNZ11 is the kind of anomaly that demands a rewrite. And anomalies, that's what science lives for. You drift in your mind's eye around its spiral arms. It's smaller than the Milky Way, about 25 times less massive, but ferocious. Hot, compact, bright, like a candle burning at both ends of space-time. You wonder, could anything have existed in it? Planets? Or even just pre-biotic conditions? Was GNZ11 the seed of something more we'll probably never know? By now, it may have merged with others, collapsed, transformed, become something entirely different. The GNZ11 of today may be unrecognizable, maybe even gone, but the ghost of it, it's here. You're seeing it, you're holding the light of the beginning in your hands, and that is no small thing. This galaxy didn't ask to break the rules, it just did. And in doing so, it helped us learn that the universe isn't just older than we thought, it's faster, more impatient, more ambitious, like a story that didn't wait for its author to finish outlining the plot. You float backward now, letting the galaxy shrink into a spiral fleck against the stars. Your journey's end is near. The impossible has become your bedtime playlist, and suddenly, the vastness doesn't seem scary. It seems alive. You think of all the things you've seen, planets raining glass, stars older than time, systems moving backwards, blinking suns, silent collapses, molten storms, chaotic orbits, lonely drifters, and this arrogant little galaxy shining at the edge of the beginning. And you realize the universe isn't neat, it's not patient, it's not even finished, but it is beautiful. You close your eyes, let the stars fall away, let your orbit flatten, let the impossible become lullaby, because sleep is just another kind of space, and you're already drifting through it. Section N tonight, we drifted through 4 hours of star systems that shouldn't exist, places so strange. They defy logic, rewrite physics, and gently remind us that the universe has a sense of humor. We began with a rebellious planet orbiting the wrong way and traveled through stars that swallow planets, burn with rhythmic heartbeats, or vanish without a trace. We visited molten exoplanets where rocks rain sideways, rogue systems flung out at impossible speeds, and ancient neutron stars that seem older than the galaxy they sit in. We danced between 3 suns. We floated beside diamond planets, runaway giants, and lonely stars with no home. we watched one galaxy form too early, too bright, too big, too soon, and didn't ask it to explain itself. Each system was a contradiction, a paradox, a testament to how little we truly know. But in that uncertainty, we found something comforting. The universe isn't broken, it's just weird. And maybe that's okay. So as you fall asleep tonight, remember you're part of a cosmos that includes backward orbits, flickering suns, and galaxies that outran the rules of time. You don't need to make sense to be worth observing. You don't need to follow every orbit perfectly. Just keep spinning. Softly, quietly, wonderfully.